Next one is aromatic hydrocarbons. Aromatic hydrocarbon contains cyclic structure with alternative pi bond. The aroma means pleasant odor. These aromatic hydrocarbons, otherwise known as benzenoids, benzene and its derivatives called as benzenoids or arenes. Example of aromatic hydrocarbons: benzene and its derivatives. Benzene with methyl, name of the compound toluene. Benzene with NO2, name of the compound nitrobenzene. Benzene with chlorine, name of the compound chlorobenzene. Benzene with NH2, name of the compound aniline. Benzene with CHO, benzaldehyde. Benzene with COOH, name of the compound benzoic acid. Benzene with OCH3, name of the compound methoxybenzene or anisole. Benzene with OC2H5, name of the compound ethoxybenzene or pinatol. Benzene with CN, cyanobenzene. These are the example of benzenoid compounds. Next is di-substituted benzene. From the substitution, these two adjacent positions called as ortho. This alternative position called as meta. Opposite position called as para. This ortho, meta, para prefix we can use only for di-substituted benzene. In the previous case, we discussed if benzene connected with methyl, the name of the compound is toluene. If two methyl group is there in the adjacent position, what is the IUPAC name? 1,2 dimethylbenzene. Common name is orthoxylene. If two methyl group bonded in alternative position 1,3 dimethylbenzene, what is the common name? What is the position of the methyl group? Meta. So what name we can give? Metaxylene. Another isomeric structure, two methyl group bonded in opposite position 1,4 dimethylbenzene. Paraxylene. Common name paraxylene. Another di-substituted benzene, benzene with OH, name of the compound phenol. In the phenol, ortho position methyl group is there. So what name we can give? 2-methylphenol in IUPAC name. Common name catechol. If methyl group bonded in alternative meta position, name we can give 3-methylphenol. IUPAC name 3-methylphenol. Common name resorcinol. If methyl group located in straight opposite to the OH group, 4-methylphenol is IUPAC name. Common name quinol. Another isomeric disubstituted benzene. If two bromine bonded in adjacent position, common name we can call ortho dibromobenzene. If two bromine atoms bonded in alternative carbon atoms, meta position, name we can give meta dibromobenzene. One more possible isomerism is there. If two bromine atoms bonded in straight opposite para position, name of the compound para dibromobenzene. Next is condition for aromatic hydrocarbons, which we can call it as aromaticity. The first condition, compound should obey 4n plus 2 pi electron rule, which is called as Huckel rule. Compound should contains 4n plus 2 pi electrons. Next condition is planarity. Compound should contain planar structure and complete delocalized pi electron. Delocalized pi electrons. These are the three important conditions for aromaticity. Based on aromaticity, we can find out given compound whether aromatic or non-aromatic. Example, benzene. It contains 3 delocalized pi electron. First, we should check 4n plus 2 pi electrons. N means number of ring. Only one ring is there. So it should contain 6 electrons. Each pi bond considered as 2 electrons. 2, 4, 6. So it's a planar structure, delocalized pi electron, and it obeys 4n plus 2 pi electron. This compound is called as aromatic. Next is naphthalene. Two ring structures are there. Total number of 5 electrons should be 10 electrons should be there. 2, 4, 6, 8, 10. And also planar structure, delocalized pi electron. Naphthalene also aromatic. Next is anthracene. Anthracene contains 3 ring structure. Number of pi electrons should be 4 into 3, 12, 12 plus 2, 14, 2, 4, 6, 8, 10, 12, 14. So aromatic. Cyclopentadiene. one ring is there, required 6 pi electrons, but only 4 pi electron is there, so it is non-aromatic. Cyclopentadiene is non-aromatic. Cycloheptatriene, it contains 6 pi electrons, so it's obey 4n plus 2 pi electron, but it is not a delocalized pi electron, so it is called as non-aromatic. Next is pentadienyl anion, 2, 4, 6 pi electron with delocalized pi bond, so this compound is called as aromatic. Heptatrienyl cation, it contains 6 pi electron with delocalized carbon atoms. It contains 6 pi electron with delocalized. So this compound also called as aromatic. Name of the compound cycloheptatrienyl cation. Compound is aromatic. Next is preparation of benzene from decarboxylation. Sodium salt of benzoic acid treated with soda lime. What is the soda lime? 3:1 ratio of sodium hydroxide and calcium oxide. They are collectively called as soda lime. When soda lime treated with sodium salt of benzoate, 2 Na is there, we can write Na2 CO3, sodium carbonate. This hydrogen bonded with phenyl part, we will get benzene. This reaction is called as decarboxylation. When sodium benzoate treated with soda lime to form benzene. Next method is benzene from phenol. When phenol treated with zinc dust, zinc readily combined with oxygen to form zinc oxide. Phenol is reduced to benzene. Here role of zinc is reducing agent. So we prepared 2 different methods of preparation of benzene. One is decarboxylation, another one is reduction of phenol. Next is chemical properties of benzene. First one is nitration. So one of the electrophilic substitution reaction. What is a nitrating reagent? Concentrated nitric acid HNO3 and concentrated sulfuric acid. What is the uses of this mixture? They produce nitronium ion, electrophile. So reaction we can write benzene treated with mixture of concentrated nitric acid and concentrated sulfuric acid, we will get nitrobenzene. This reaction carried out in 3 different steps. Step 1, formation of electrophile. Meaning of electrophile, electron a deficient species. formation of electropile. The role of sulfuric acid, it acts as a proton donor. This is structure of sulfuric acid. The mixture of nitric acid and sulfuric acid produce nitronium ion. Oxygen has a lone pair. This lone pair made bond with proton from sulfuric acid. Now we will get oxonium ion. What is the oxonium ion? This oxygen will carry positive charge. It indicates it required electron. This oxonium ion take the electron from NO2. Now NO2 will become NO2 plus and water. This step is called as formation of electropile. Step 2, formation of rhenium ion or formation of carbocation or rhenium ion. Benzene has alternative pi bond. This electropile bonded with benzene to form transition state rhenium ion H NO2, carbon will carry positive, that is why it is called as carbocation. This is step 2, formation of carbocation or rhenium ion. Step 3, deprotonation. From the rhenium ion, proton is removed. NO2 is there. Now we will get nitrobenzene. This proton will be bonded with HSO4 minus. This HSO4 minus will become H2SO4. So nitration of benzene carried out in 3 different steps: formation of electropile, formation of rhenium ion, final step will be deprotonation. Next is halogenation. Example, when benzene treated with chlorine in presence of Lewis acid like ferric chloride occur in electrophilic substitution reaction, will get chlorobenzene and hydrochloric acid. Same benzene treated with excess of chlorine in dark condition, all the 6 hydrogen atom will be replaced by chlorine. We will get hexachlorobenzene. Remaining 6 chlorine combined with 6 hydrogen to form hydrochloric acid. Name of the compound hexachlorobenzene. Same benzene treated with excess of chlorine in presence of UV light, heated at 500 Kelvin. Now occur in addition reaction, we will get benzene hexachloride BHC, which is one of the pesticide. Benzene hexachloride. In dark condition, substitution reaction will take place. Hydrogen replaced by chlorine in presence of light with excess of chlorine. Occur in addition reaction, we will get BHC, benzene hexachloride, one of the pesticide. Next is bromination. For bromination, instead of chlorine, we can take bromine. Instead of FeCl3, we can take FeBr3. You will get bromobenzene. Next is Friedel-Crafts alkylation. When benzene treated with chloromethane CH3Cl in presence of anhydrous aluminum chloride, this hydrogen should be replaced by methyl. Benzene will become toluene. Byproduct is hydrochloric acid. Second one is Friedel-Crafts acylation. Same benzene and catalyst anhydrous aluminum chloride. Another reactant should be acetyl chloride CH3COCl in presence of anhydrous aluminum chloride. This hydrogen should be replaced by COCH3. We will get acetophenone, otherwise known as methylphenyl ketone. Name of the compound acetophenone. Next is sulfonation. For sulfonation, when benzene treated with concentrated sulfuric acid, we will get benzene sulfonic acid. Next, I will summarize electrophilic substitution reaction of benzene ring. When benzene react with concentrated nitric acid and concentrated sulfuric acid, benzene treated with concentrated sulfuric acid treated with chlorine in presence of FeCl3, Lewis acid, treated with excess of chlorine in presence of anhydrous aluminum chloride and dark condition, treated with excess of chlorine in presence of light and heat, also heated at 500 Kelvin. Benzene treated with chloromethane in presence of anhydrous aluminum chloride. Benzene treated with acetyl chloride CH3COCl in presence of anhydrous aluminum chloride. The first reaction, when benzene treated with nitric acid and sulfuric acid, we will get nitrobenzene. This reaction is called as nitration. When benzene treated with sulfuric acid, we will get benzene sulfonic acid. This reaction is called as sulfonation. Benzene sulfonic acid. When benzene treated with chlorine in presence of Lewis acid, occur in chlorination, we will get chlorobenzene. Then benzene treated with excess of chlorine in presence of aluminum chloride and dark condition, we will get all the 6 hydrogen atoms are replaced by chlorine. We will get hexachlorobenzene. When benzene treated with chlorine, excess of chlorine in presence of light, UV light, we will get insecticide, benzene hexachloride, BHC, benzene hexachloride, one of the insecticide. Next is benzene treated with chloromethane in presence of anhydrous aluminum chloride. Occurring methylation, we will get toluene. Name of the reaction, Friedel-Crafts alkylation. Toluene or methylbenzene. Next one, acetyl chloride treated with benzene in presence of anhydrous aluminum chloride. We will get acetyl benzene. This reaction is called as Friedel-Crafts acylation. Next is carcinogenicity. When organic compounds involved in incomplete combustion, they produced polynuclear hydrocarbons. This kind of polynuclear hydrocarbons toxic in nature. Some example of polynuclear hydrocarbons: one comma 2 benzanthracene, next one is nine comma 10 dimethyl, 1 comma 2 benzanthracene. Another example of carcinogenic reagent, one comma 2 benzpyrene. Another example of carcinogenic agent, 1 comma 2 5 comma 6 1 comma 2 5 comma 6 dibenzanthracene. When organic compounds involved in incomplete combustion, they produced polynuclear hydrocarbons like 1 comma 2 benzanthracene, 1 comma 2 benzpyrene, 9 comma 10 dimethyl, 1 comma 2 dibenzanthracene, 1 comma 2 5 comma 6 dibenzanthracene. Such kind of polynuclear hydrocarbons can produce cancer, so they are called as carcinogenic agents.